Hi everyone, welcome back to Fun with Electronics. My name is Brian. During our last live stream, we had a few audio and internet issues, so we're going to be releasing this video to go over some of the important concepts from our last live stream. So first of all, we have the batteries. So the batteries are essentially the power sources of our circuit, and they provide something called voltage. Voltage forces electricity to go through our circuit and power our components. So next up, we have the battery holders. And batteries holders essentially, well, they hold batteries, and they allow us to combine batteries and put them in our circuit. An important thing to note is that batteries have a positive and a negative end, and so do battery holders. So you can think of electricity as flowing out of the positive terminal and into the negative terminal in a complete circuit. Next up, we have two of our most important components, LEDs and buzzers. So LEDs are essentially mini light bulbs, and they have a positive terminal and a negative terminal. And when you flow electricity into the positive terminal and out the negative terminal, the LED will glow. Now buzzers are pretty similar in that they have a positive terminal and a negative terminal. You can tell the positive terminal by looking at the plus sign. And when you flow electricity into the positive terminal and out the negative terminal, then it will make a sound. And finally, we have resistors and alligator clips. Resistors resist current in a circuit. If we didn't have resistors, then we might be sending too much power through our components like the LED, and this could damage them. So it's important to have a resistor to help resist some of the electricity and prevent damage from occurring. We also have alligator clips, which essentially act as our wires to connect components together. And it's really important to be safe with them, as if you pinch someone with them, it could hurt a lot. After we have all of our components, we could combine all of them in something called a closed loop, or a circuit. So you could have a circuit like this, where you would have electricity flowing out of the positive end of the battery, into a resistor, which would resist some electricity, and then into our LED. And then it will flow back into the negative end of the battery. And it's really important to have a closed loop here to ensure that electricity flows through the entire circuit. Now, if we had this set up, then our LED would always be on, and the only way to turn it off would be to disconnect one of the components from the rest of the circuit. However, what if we want to control where electricity flows or not? Well, this is where we have something called a switch come in. So we could have a little device here called a switch. And essentially what it would do is that if we had a device here that could open and close the circuit, depending on where it was on or off, we could be able to control whether or not electricity flows through this loop. So we could accomplish this with our button. So the button functions as the switches in our circuit, where if this button is on, then electricity is allowed to flow through it. However, if we push the button will no longer allow electricity to flow through the circuit. So by pushing it, we can open and close our circuit. Now, the best way to learn about how the button works is to do some examples. So Ethan is going to walk through showing us how to build some of these circuits. For instance, we're first going to build a circuit where we can turn the LED on or off. Then we'll build one where we can turn the buzzer on and off. And then we're going to do more of a challenge circuit where we're going to build something called a parallel circuit. Ethan will explain more of how this works when we get to it, but look forward to that.
Hey guys, I'm Ethan. Today I'm going to be teaching you about some simple circuits that include buttons. So the first circuit that we're going to use that uses a button is an LED based circuit. So without a button, of course, the LED would just turn on and stay on. There would be the electricity coming from the battery, going to the resistor where it's going to be limited, so the LED does not burn out. And then of course it goes to the LED, so it actually turns on, and then back to the battery and to ground. So this is nice and all if you just want the LED to be on, but what if you want to turn it off? Well, this is where the button comes in. So in order to make a button work in the context of a circuit, you need to include it inside of the overall circuit circle, I guess. So now you do that by basically unplugging two alligator clips from each other and then putting it in between them. If you don't have an extra alligator clip like in my circuit, you can just get another one and put it into the circuit. Now you might be thinking, wait a second, the button just turned the LED off. Well, if I press the button, it'll turn on, and if I press it again, it'll turn off. And this works because the button essentially disconnects and then connects to the circuit, and the circuit can only run if it's connected all the way around. The next button-based circuit that we're going to use is a circuit that has a buzzer inside of it. And of course, a buzzer's purpose is to buzz. So I have the circuit disconnected just so my eardrums don't get blown out. But let me just show you that if I connect the circuit, the buzzer starts buzzing. So let's just say I don't want to have to unplug the circuit every single time I want to turn off the buzzer. Well, just like you may have guessed, this is where buttons get into the picture. So for now, I'm not going to actually plug in the buzzer, so you won't really see the difference at first, because I still want to keep my eardrums intact. So now you see that just like in the LEDs circuit, I put in the button inside of the general circuit between two wires. And now after I've done that, I will connect the buzzer. And as you can see, the buzzer is not buzzing. But if I press this button, it's buzzing. If I press it again, it's not. So now I can blow out my eardrums when I want to, using the power of buttons. So now that we went over how to make a buzzer button circuit and an LED button circuit, we can now just learn how to merge them together. If we did a normal circuit, which is just one straight line across, we might actually not be able to do this. This is because both of these take up a certain amount of electricity, which the battery simply cannot supply. We would need a bigger battery that supplies more electricity in order for this to happen. But there's actually a trick that some electricians use to power multiple components with the same amount of electricity as they had before. While we won't go into the details of how this exactly works, it's called a parallel circuit. So essentially, instead of one pathway from the power to the ground, you have two pathways. So first, let's put in the first pathway. So here we have the LED wire, and we're going to just put it in to connect to the power, and this connected to the ground. So look at this. The LED is now on. And now let's put in the second pathway. So it's going to have a buzzer inside of it, and we're just going to attach one side to the power, just like the LED side, just like the LED had, and one side to the ground. So as you can see, there are two different pathways present here. This little jumble over here has the buzzer, while this wire has the LED. And obviously this is not a straight line, but since we have two pathways, we get to have basically split the electricity in order for both of the components to work. So now let's make this even better by including a button. So I'm going to take these two wires over here, which are not exactly connected to any other component, and put the button in between. And then once I've done that, I'm going to connect back the buzzer to the circuit, to the ground, so it can actually buzz. And now I can efficiently turn it off. When I include the button inside of the parallel circuit, there's also another phenomenon that happens. It's important to note that while the parallel circuit allows for electricity to be diverted and split into two, that still means the electricity is split. So when I press the button and the buzzer turns on, you might notice that the LED becomes a little bit dimmer, because some of the electricity that would have been going into the LED is now going to make the buzzer buzz. So those are all the circuits for today. I hope you enjoyed it, and if you have any questions, any at all, feel free to email us, and we'll put the email in the description down below. For more content, be sure to subscribe so you could get notifications, or in order for you just to simply browse through our videos and see what you want to learn.